One common complaint of many students is that they cannot see the application of mathematics in the real world. In this video, we are going to show the application of mathematics in solving mixture problems. Here's the first of the three problems in this video. Crystal created a metal containing 47% nickel by combining two other metals. One of these other metals weighed 6 milligrams and contained 35% nickel. If the other weighed 9 milligrams, then what percent of it was nickel? Now let's solve this problem together. One technique is to create tables in order to organize our data. Here, Crystal created the metal out of two other metals, and let's call the other metals as metal A and metal B. So let's put here the strength and the weight rows, and let's complete our table. Now, based on our given, Crystal created a metal containing 47% nickel, and this is achieved by combining 6 milligrams of metal A containing 35% nickel and metal B that weighed 9 milligrams, but we do not know what percent of it was nickel. And so we let X be the variable representing the percent of nickel for metal B. Then let's use a different color. So red is for the unknown, white is for the given. And we will use color yellow for the computed value. Now, if metal A weighed 6 milligrams and metal B weighed 9 milligrams, the combined weight would be 15 milligrams for the created metal. And then let's add another row for the amount of pure nickel. If 47% of the 15 milligram metal is pure nickel, then 0.47 times 15 would represent the amount of nickel for the created metal. And this gives us a value of 7.05. Now for metal A, multiply 0.35 times 6 to get the amount of pure nickel, and that gives us 2.1 milligrams of pure nickel for metal A. And for metal B, multiply X times 9 milligrams to get 9X, where X is a decimal number representing the percentage of nickel for metal B. Now from this table, the amount of pure nickel in metal A plus the amount of pure nickel in metal B would be the combined pure nickel for the created metal. And so we now have this equation. This 2.1 plus 9x, that is equal to 7.05. The amount of pure nickel for metal A plus the amount of pure nickel for metal B is equal to the combined nickels for metals A and B in the created metal. So from here, it's just a matter of solving this equation. So first, solve for X by subtracting both sides by 2.1 and simplifying to get 9X equals 4.95 and divide by 9 both sides to get X equals 0.55. And then convert this to percent to arrive at X equals 55%. So the strength of metal B is 55%. And our problem is now, let's go to problem number 2. Here's problem number 2. Let's say James and his brother mixed together two types of soil to make 10 cubic yards of soil with 35% clay content. They use 8 cubic yards of a soil with 30% clay content and 2 cubic yards of another type of soil. What was the clay content of the second type of soil? So by just reading this problem, it could appear to be very confusing, but again, the technique is to create a table. So we have two types of soil. We have soil A and soil B, and we mix these two types of soil to arrive at this mixture at the last column. Then let's organize the given. First, we have 10 cubic yards of resulting soil mixture with a 35% clay content. Then the volume of soil A is 8 cubic yards, and this has 30% clay content. Soil B is 2 cubic yards, and we do not know how many percent of clay is in soil B. So we let that to be X. X is a decimal number. Now, if 30% of 8 cubic yards is clay, then 0.3 times 8 would be the amount of pure clay for soil A, and that is 2.4 cubic yards. For soil B, we multiply X times 2 to arrive at 2X, representing the amount of pure clay for soil B. And for the mixture of soils A and B, we have 0.35 times 10 to arrive at 3.5 cubic yards for the clay content of the mixture. Then from here, we can now form this equation. 2.4 plus 2x equals 3.5, meaning the clay content for soil A mixed with the clay content with soil B would be equal to the sum of the clay contents of these two types of soil. So solving for x now, so we have 2x equals 3.5 minus 2.4. simplifying to 2x equals 1.1, and dividing both sides by 2 to arrive at x equals 0.55 or 55%. So from here, the percentage of clay content for soil B is 55%. Let's go to the next problem. Here is problem number 3. Vegetable oil, which costs $2.50 per ounce, is made by combining soybean oil, which costs $1.30 per ounce, with canola oil, which costs $3.20 per ounce. Find the number of ounces of soybean oil and canola oil required to make 11.4 ounces of vegetable oil. So again, the strategy is to create table. So we organize our data this way. We have here the soybean oil, the canola oil, and the vegetable oil. The cost of the vegetable oil is $2.50 per ounce. The cost of the soybean oil is $1.30 per ounce. And the cost of the canola oil is $3.20 per ounce. We know that the resulting mixture is 11.4 ounces, but we do not know how much of soybean oil and how much of canola oil are used in the mixture. So we let them to be X and Y respectively. Then for the total price, if the cost per ounce is $1.30 for the soybean oil, and there are X ounces of that soybean oil, then the total cost would be the product of $1.30 and X. The same explanation for the canola oil and for the vegetable oil. For our equation now, we'll have two equations in two variables. First, the combined volume of the soybean oil and the canola oil would be equal to the mixture. So that means X plus Y is equal to 11.4 ounces. When you mix the soybean oil and the canola oil, this is the resulting mixture. Then the next equation would be for the total price. The price of the soybean oil plus the price of the canola oil is equal to the price of the mixture. So we have 1.30x plus 3.2y is equal to 28.5. Let's call the first equation as equation 1. And this next equation as equation 2. We have here a system of two equations in two unknowns, and there are so many ways of solving this. In this case, let's use substitution method. So from equation number 1, let's solve this for x, and let's call this as equation 3. And let's substitute this result to equation number 2. So we now replace this x by 11.4 minus y. All the rest are copied, and then distribute 1.30 to this binomial, and simplifying, we arrive at this next equation. Combining similar terms, we have this result, and solving for y, we have 1.9y equals 28.5 minus 14.82. And simplifying the right side to arrive at this, and dividing both sides by 1.9, we have y equals 7.2 ounces. So we now know the volume of the canola oil to be 7.2 ounces. We can now solve for the volume of the soybean oil. Since soybean oil is equal to the total volume minus the volume of the canola oil, we now have this equation, and the result is 4.2 ounces. So these are now the respective volumes of soybean oil and canola oil. X is 4.2 ounces and Y is 7.2 ounces. So the main strategy here is to organize your given in tables like this. We hope to see you again in our next video. Bye for now.